Hello my dear students, in this video we are going to continue with the linked lists. Let us have introduction. The main disadvantages of using arrays is arrays are static in nature. They are fixed in size. Here the arrays cannot be used for extending or it cannot be used for reducing. If we want to push the data items into the array, then we have to shift all the elements from the lower order to higher order, and if we want to delete an element from the array, then we have to shift all the data items from higher order to lower order. In order to address this limitation, we have got linked list that allocates memory for each data item dynamically at the time of execution of a program using new and delete operators. Now let us see a node that consisting of two parts. The first one is data and the second one is link. So here link is the reference or address pointing to the next node. Both of these two part together we call it as node. And here you can see pictorially we have got nodes, that is 30, 20, 50 and 10. Here you can see this arrow represent it is the reference to the next node, that is address to the next node. Here you can see the last node consisting of the cross mark that indicates it's a null pointer which is pointing to nothing. This indicates this is the last node of the linked list. Now let us have the types of linked list. There are three different types of linked lists. The first one is singly linked list, in short we call it as SLL, and the second one is doubly linked list, in short we call it as DLL, and the third one is circular linked list, in short we call it as CLL. Let us continue with the first one, singly linked list. Here each node is pointing to only one node is called as singly linked list. Here in the diagram you can see the start is the pointer that indicates this is the beginning, and here it is pointing to the first node 50, and this 50 is pointing to the next node 40, and then 70 and 20, and the last node represent it is a null. Here each and every node is pointing to only one node, hence it is called as singly linked list. Now let us continue with doubly linked list. Doubly linked list points to the previous node and the next node. Here in the diagram you can see, so this is called as backward, that is it is pointing to the previous node, and this one is forward, it is pointing to the next node. At the middle we have got data, it is also called as information. So let us see, back means this particular arrow onto the left hand side, it is a pointer field that contains the address of the previous node, and next is forward, so that is the next arrow mark that is pointing to the right. Forward is a pointer field that contains the address of the next node, and here info that contains the actual data. And here in the diagram you can see we have got the start pointer pointing to the first node, second node and the third node. Here you can find the cross mark. If we have the cross mark onto the left hand side, this indicates that this is the first node, and if we find the null onto the right hand side, then it is the last node. Now let us have circular linked list. If the reference of the last node is pointing to the first node in a linked list, then such a linked list is called as circular linked list. Here in the diagram you can see start, header node, and here we have got so many nodes, and the last node reference is again pointing back to the first node. So such a linked list is called as circular linked list. Let us continue with the operations on linked list. The first operation is creating a linked list, second one is traversing a linked list, third one is inserting an item into a linked list, fourth one deleting an item from the linked list, fifth one searching an item in the linked list, sixth one merging two or more linked lists. Let us continue with creating a linked list. How to create a linked list? Here in the diagram you can see struct node curly open brace int data node asterisk symbol link means what? This is the pointer variable, it is a link or reference. data represent the actual value that is stored in a node. Here you can see this pointer variable of type node is a structure type. So hence this type of structure definition is called as self-referential structure definition. Now here you can see curly closing brace, and after that we have written node is the user defined data type, and then we have written asterisk symbol node1, so it is a pointer variable of this type, and then comma asterisk symbol node2, so it is indirection operator. So this is the second object pointer of this type. You can write either this way, or you can write struct node curly open brace int data node asterisk symbol link curly closing brace asterisk symbol node1 comma node2 and so on. Then put semicolon. Once we define a structure, we can create any number of object of this particular type. And here we will see the data and link. Each node consisting of two parts. The first part, that is leftmost part, was data, that consisting of the actual value, and the link is the reference or address that is pointing to the next node in a linked list. Here data will take 2 bytes. Why? Because data is integer type of data. The next link also takes 2 bytes. Why link takes 2 bytes? All the pointer variables irrespective of the data type will take only 2 bytes. So hence 2 plus 2 total 4 bytes. So it is going to take 4 bytes. Each node will occupy 4 bytes of memory. Next you can see here how to create each node. Node asterisk symbol new node means what? This is a variable, that is pointer variable of node type, and then we are writing p is equal to new node. So here new is the keyword which is used to allocate memory dynamically at the time of execution. Next you can see here data of p, that is pointer. Data of p is equal to num. Num is the number, actual value that is to be stored in a data part of the node. Next link of pointer is equal to null. This is how we are going to create a particular node. And now it's time to have a programming example so that we can understand how we will be able to create a linked list. This is one of your lab programs. For that I will take you to my laptop screen. Here we will write a single line command. Write a program to create a linked list and appending nodes. Now let us continue with the preprocessor directives. Hash include iostream.h header file. Next hash include conio.h header file, and then we will write here class linked list, or you can say we'll write link list curly open brace, and here in a private member we are going to define one structure called node curly open brace, and here we are going to write int data, then node asterisk symbol, that is pointer pointing to itself. So here you can say link, and then we will write curly closing brace and start pointer. Next we'll write here public section. Under public section we are going to write link list. So that is a constructor. You can see here it does not have any return type, and the name of this function is same as that of the class name. Next we'll declare one more function, that is void print. Next void append. Now we'll write void count. You want to count how many elements are present. And here we're going to put curly closing brace that indicates the termination point of class linked list and put semicolon. Now we are going to define all these four functions outside the class definition using scope resolution operator. Now we'll write the first one, link list scope resolution operator link list. That is constructor which is used for initialization. Here we'll write start is equal to, it should be null, and null should be always written in capital. Yes. Next we'll write void link list scope resolution operator, and we'll use print function and curly closing brace. Here we'll write if start is equal to null, then it should use the statement cout. Here we'll write cout, and in a double quotation mark we'll write linked list is empty because it is set to null. Now we are going to write the else part. Here we will write return, then the traversing, next cout linked list contains put semicolon, and then you're going to write node pointer p is equal to start, then while looping structure. Here we are going to write p is not equal to null. Curly open brace cout we'll write here some space, and then we will write insertion operator, then pointer p, and this arrow mark represent it is pointer to object operator in order to access the members of the class. So here we'll write data, and then we'll write p is equal to p and accessing link. Next curly closing brace and one more curly closing brace for ending this print function. Next we'll move on to void linked list scope resolution operator append function. Here in append we are going to use one variable, that is int num. Okay, I think we forgot to write here int num. Let us write here in a declaration as well. We will write int num. Okay, come back to this function definition, curly closing brace, and now we'll be able to write node asterisk symbol. We'll write new node. New node is a pointer pointing to node. Next we'll write new node is equal to new, then space you have to give, then we have to write node. Okay, so this is how dynamically we are going to create a pointer. Next we will use new node, then arrow mark member access operator, data is equal to item, otherwise we'll write here num because we have taken number. Next new node member access operator arrow, then link. Here always node consisting of the first one is data and the second part is link. Now for the first time it is linked to null. Then we'll check the condition. If start is equal to null, it should be capital, then curly open brace, we'll write start is equal to new node. Then cout, write here endl, and then we will write that number, and then that number is inserted as the first node. We'll write endl. Now curly closing brace, else part, curly open brace. Here we'll write node star p, then is equated with start, then while p pointer is pointing to link not equal to null. If this is not equal to null, till it is not equal to null, so it is going to iterate. So p is equal to p, then we'll use link and put semicolon, p link, arrow mark, link is equal to node, that is new node. Cout endl, here we will use num, then is inserted we'll use endl, then curly closing brace and curly closing brace for the function definition, that is append function definition. Now we'll go for the next function, wide link list scope resolution operator, and we'll use count function, then curly open brace, and here we are going to declare one more pointer of type node star p, then we'll declare a local variable int c that represent count is equal to 0, then looping structure for p is equal to start and p not equal to null. So it has to start from the beginning, that is start pointer, and till p is not equal to null, and put semicolon, p is equal to p arrow mark link. Then we'll write cout endl, and in a double quotation mark here we'll write number of elements in the linked list is equal to endl, then curly closing brace of this count function. Now it's time to define main function. We'll write here void main curly open brace. Here we will write link list pointer object is equal to new link list. Here we are creating this pointer object dynamically using new operator. Next we'll write obj using arrow mark, that is one of the member access operator to pointer to object. Next here we'll write, first we'll call print and then obj, then it should call append function by inserting element 100. Next obj, and then we will go for printing this element. Next it has to count. We'll use obj, then we'll count. Similarly, we will write obj, then member access operator we'll use now append, and here we are going to insert 200, that is the second element, and it has to be printed, it has to be displayed. Here we are going to use print and then obj, next count. Again one more element we are going to insert, append. Here you can take 300, next obj, print, similarly obj, count. Here we'll write get ch, then curly closing brace, and now we'll go for compiling. So here it is a warning. I think we have not used this one. So looping, after looping structure, this has to get increment. So let us write C++. So that is count plus plus. Now let us compile once again. Now it is success. So click on run. Here you can see linked list is empty for the first time. 100 is inserted as the first node. Linked list contains 100. Number of elements in the linked list is equal to. Now it is not displaying the result. So let us see. So count consisting of here we have to write C. So it has to display the result. Now let us compile once again. Success, there is no error. Click on run. Here you can see for the second time it is displaying as linked list number of elements in the linked list is equal to 1. 200 is inserted. Linked list contains 100. 200 number of elements in the linked list is equal to 2. Linked 300 is inserted. Linked list contains 100, 200, 300.
That's all in this video. Thank you very much for watching this video. We will see you in the next video.